Hello, Mr. Ryan. Okay, so today we talk about the binary tree, the width, maximum width. Okay, so binary tree, you already know binary tree, yeah? The nodes. Binary tree is one of the graphs, yes? Graph. Like, how many nodes how many children can the node have?
2.
Maximum, yeah, maximum.
Yeah, that's exactly what I was about to say.
Okay, so let's define
Hey, what's that?
Okay, that's good. So
it's nothing.
let's define the width. The width is the level. For a level, is the distance between the leftmost node and the rightmost node. Okay, and we're going to find the maximum width, which is the maximum width of all levels. Yeah. So, for example, how many nodes? The distance between leftmost node 1 and 1 is 0, yeah? Because it's just one node, right? For the first level, yeah? Alright? The level 2, level 1, what's the distance? Yeah.
2.
2, right? Because there are 2, yeah? 2.
Yeah.
And how many nodes can you, the distance between the nodes in level 3? So you can put the one node here and the most.
4.
4, yeah. 1, 2, 3, 4. Yeah, okay. And okay, so if I have another node here, so what's the difference between this and this? Interesting, yeah.
Wait.
Right? What's the difference between this and this? So
3.
let's write it, yeah. So it's like that, yeah. You see, here are another 2, yeah. Okay, so 1, 2, 3, 4, 5, 6, 7. Got it?
7.
Yeah, 7. So you can squeeze all the nodes, yeah. Got it? And we want to calculate distance, needs to be including the leftmost node and the rightmost node, okay? So given this, how do we calculate it? I mean, how many ways of
You draw the invisible node.
Yeah. How many ways are we going to can we do to traverse the binary tree?
Breadth search, depth search.
Breadth search and depth search.
Yeah. Rub it out.
Okay, so can we use the breadth search? Can we use the depth search? Which one is better, you think?
I think breadth search.
Breadth search. And how do we actually do the breadth search?
Level by level.
Level by level. And what kind of data structure are we going to use to implement the breadth search? We want to use what kind of data structure do we need to implement the breadth search?
Q.
Q, yeah? Q. What's Q?
Like a thingy.
Well, first in.
First out.
First in, first out, okay.
FIFO.
FIFO. And in Python, we are using what kind of the data structure? I mean, what kind of the function class are we going to use to declare a queue? What is it?
DQ.
DQ, okay. What's that?
That one did Q.
Okay.
I answered it before you said.
Okay.
You
So
said half of a question.
so DQ, yeah, because I asked that question a lot, yeah. So you know the answer. DQ. So
So what's the point saying it over and over again?
just to test you, okay? Come on, guys. So this, how can we use the breadth search to calculate the distance?
Okay, so
So how can we do this? In order to find the distance, one way of doing this is that we need to have a way to calculate the coordinate. Yeah, let's say the coordinate of the leftmost and the rightmost, right? Alright. And we can find out that the rightmost for a node, if this is parent, the coordinate difference between its left and right is what? How many nodes are, right next to it, right? Yeah? Okay, so if we define the way of these, then we know the right node is +1 of the left node, right? Yeah? So one way of doing this is if we go to the left, what do? We can multiply by 2, yeah? If this is 0, we can times 0 here, right? It's still 0, but here is 1. And if we times 2, here is 2. Alright? Got it?
Missing one, just kidding.
Does it make sense? Okay, let's take an example. Like let's say easy one. Okay. Let's say if you want to calculate the distance between 5 and 4. Okay. If you want to find the difference between 5 and 4. Ryan, are you alright? Yeah. Look, this is 0. This is what?
This
Times 2.
Times 2. 0 times 2 is still 0.
0, and here is 0. Right? Times 2 add 1, this is what?
1.
1. Okay, what's the value of this? I mean, if I times 2, this is times 2. If I have no here, that will be 2, right? Times 2, here will be 2, right? Right? And then here, what's that? Times 2 plus 1.
3.
3, okay. So I know this is 3. And then this is 0. So the distance is what? 3 minus 0 plus 1. So can we verify it? Yeah? Okay,
Can you just rub out one of them?
yeah, so look, you can have 4, right? So this initial value, does it matter? Can we use the 1 here? 1 here. Okay, let's do this. 1 times 2 is 2, right? 2 times 2 is 4, right? 2 times 4, 4 plus 1, right? 5, right? 1 times 2 plus 1 is what? 3. Yeah? Yeah? 3 times 2, 6. And that's 7. So 7 minus 4 plus 1 equals what?
It is 4.
This is 4. Okay, so it's okay, yeah, the initial value. So look, yeah, if it goes to the left, you multiply by 2. If it goes to the right, you multiply by 2 plus 1, right? Does it make sense? Okay? So in this case, we can do this breadth search and then exploring the nodes of the same level at once. Yeah? And each one at each level, we can know the distance between the leftmost node and the rightmost. And when we're expanding the children into the next level, if it's the left node, we multiply by 2. If it's the right node, we multiply by 2. And what? And what?
And B plus 1.
And plus 1. Yeah, that's it. Okay, let's do this.
Yay.
Let's do this coding.
And then
Define max width. Root, okay? And okay. If it's an empty tree, what's the answer of the? What's the answer? 0, yeah. Okay, and then Q equals DQ. And at the beginning, we need to put a root in, and then the initial value, let's put a 1, okay, or 0, okay, let's put a 1, okay.
0 could be better.
Okay, 0.
I'll put 0.
Okay, 0, okay. And
0
then,
or 1.
so can you tell me how do we
0
implement?
or 1.
How do we implement the breadth search? We need to check when there are nodes. How do we check? How do we implement the breadth search? We at the beginning we put a root.
We need the answer.
Yeah. So at what condition how do we do this? How do we usually implement the breadth search?
Q.
Yeah, I know. So we put the root in, and then what's next?
Then
We take the root now out, and we
Yeah.
put the kids in, right?
yeah, the kids.
Okay. So at here, what should we write here?
Copy
What?
and read the pop.
At the beginning, when are we terminating the breadth search? When do we stop doing the breadth search? When do we stop doing the breadth search?
While Q.
While Q. What does while Q mean?
While the Q keeps on.
While Q is what? It's not what? While there's nodes in the Q. While Q is not empty, right?
Yeah.
Okay. And then how many? While Q is not empty, so current nodes in the Q belong to the same level, yeah? Yeah? So how many nodes are there in the Q at the moment?
1.
Yeah, I know, but how can we do this? SZ equals what?
What's SZ?
Size, short for size, or any variable. Equals what? What Q? A function.
The length of the Q.
Yeah, the length of Q. And then here, at the beginning, we need to say the left and right, yeah? Let's say L and R At the beginning, the left is the negative infinity, right?
Negative infinity.
And now r is what?
Super small.
The r is what?
Super
The
big.
rightmost is what? The rightmost is what?
Infinity.
Mass dot infinity, yeah?
I'm minus math.
Okay, so
Infinity.
we have the left boundary, right boundary set to infinity at the beginning. And then, what should we do? For, we need to, because they're currently,
B.
okay, let's do this, let's put it in n, okay? They are currently n nodes in the current level, yeah? For underscore in range. Let's repeat n times, right? Right?
Cool.
Okay, and then let's call it current, let's call it C. C and then this is what? This is the value, yeah? Value equals what? Let's pop it. C and V. C is the root, V is the value. So what should I do? Q dot what?
Pop.
Pop what?
Left.
Pop left, yeah? Because we are taking the nodes from the beginning of the Q. It's pop left, right? If it is pop, what does it mean? If it's just pop, what does it mean?
Is
Taking nodes from which side?
left. No, yes.
Pop left is from the left side and pop is from which side? If it's a Q, DQ, right? What's DQ mean?
DQ double-ended.
Okay, then pop left is taking nodes from the left side and
You'll take it from the right.
right side. Yeah, that's what I mean. Yeah. Okay, so we take the nodes from the left side, and then what should we do? What should we do? We should update the L and R. Yeah. L equals what? The left hand side is what? Mean of L and V, right? And can you tell me R? R equals what? R equals what? Now the
Max.
yeah, max. What? V what? V is the node. The nodes
V.
yeah, V and what? We what's this doing? We want to update the left.
R.
Yeah, you're right, yeah. And then now if C dot left, they are left nodes. So what should we do? Q dot append what?
A pen.
Append what? Append what? What should we append? The node and the value. So what should we do? Q dot append what?
Root.
No, root. The current node is C. Okay, and then here is C dot right. Okay, so C dot left, and then what? C dot left. What's this value? Q dot append.
Car.
C dot right. And what? Come on. The value. If we go to the left, what happened? What happened to the value V?
Times 2.
V times 2. And if you go to the right, what happened to the V?
Times 2 plus 1.
Times 2 plus 1. Okay, and after this, we have updated the F and right. And then answer, let's call it answer. Answer here equals 0, okay? So answer equals max answer and what? What? And then return what? Come on. Yeah? We know at least.
Something minus 20.
Okay, so at this level, we know the L and R. The left and right. So what's the width of that level? Which is this level? So here a node, and here is L, here is R. What's the level? What's the distance?
Right minus M.
Plus 1. You need to plus 1, eh? Yeah?
Okay.
Because look, if it's 2 and 3, what's the distance? It's 3 plus minus 2 plus 1 is 2, right? It's not 1, right? Got it? Am I right?
Yeah.
Okay. So R minus L plus 1, and then we want to record the maximum, right, of the width answer and return what?
Answer.
Return answer. Okay, so look, LR at the beginning is the infinity, and then we're expanding the n nodes of the current level, right? By expanding the nodes, we use this V, right? We use the V to update the L and right? Am I right? Yes? Alright?
Mm-hmm.
Mean equal, yes. Actually, this is opposite, right? This is opposite, right? Because the left you want to be the maximum, and right you want to be the minimum. So L will be the minimum of L, right? Yeah? R equals maximum of V, right? Am I right? Because R, the R boundary, right boundary at the beginning is negative infinity. So any number will be bigger than negative infinity. Yeah? So these two statements are going to update the left and the right boundary. Yeah? And then if they are the left nodes, we expand the node, we insert the nodes into the back of the queue, which is append, right? Yeah? What's the, if I want to, this is DQ. Append is append this direction at the back. If I want to put it at the beginning, what's that? Append what?
Append the left.
Yeah, append left. Okay, that's what it means, double NDQ. And then we exploring the left nodes and right nodes at the back of the queue, and then after these four, we are finishing expanding the nodes in the same level. And then now we know the R and L, and we can compute the width of that level. And then we keep answer is the maximum level of maximum width of all levels. This is the answer we are looking for, right? What's the time complexity?
N.
What's N?
Number of legs
You know what?
binary tree.
Okay, what's the space complexity?
O. N.
Why is ON?
Q.
Yeah, because we're using the Q, okay? Yeah, times complexity because we need to visit each node once, right? Yeah? Am I right? If there are n nodes in the binary tree, we need to visit each node once, am I right? Yes? Does it make sense? Yeah? Okay. Okay, I'm going to...
No.
Okay, just these two. Okay, what's this? What's these two? Come on, you see it. What's these two?
I did not.
So we are expanding we are popping that to the Q, the element from Q. We need to update L and R. Yeah, L and R. Yeah, L equals what? Yes? The left equals what? We want to update the L, the left boundary of the V. Okay? Left equals what?
Mini.
Yeah, mean. Mean. We want to get the mean value. Mean of what? And that one is the max, yeah?
Go cross.
Yeah? What? Yes? Yeah? We want to update the L with two values. Come on, think about it. It's easy.
V.
Yeah, V and what? Yeah. And what? L, yes. Well done, yeah. You see, it's not that bad, okay? It's easy, okay? Okay, that's it for today. Say bye-bye.
Bye.
Bye-bye. That's it.